100 students. Today we're talking about subnetting. A lot of you have been waiting for me to dig into subnetting and explain it. I have a document that I'll be posting to you on our course website called the Subnetting 12-Step Program. So I'll explain that a little bit later. But for now, what we're going to do is I'm going to share my desktop. We're going to be taking a look at a screen drawing application. And I will be going through what I consider the core ingredients of how to subnet a class 4 IP version 4 address. On Friday, I will be going over IP version 4 classful and classless schemes, which is something that is part of this discussion. But tonight is going to be dedicated to subnetting. All right, I'm now going to share my desktop. And Stephen, if you could make sure that you can actually see my drawing application, can you?
Yes.
So you can see the smooth draw program?
Yes.
All right, great. So let me go ahead and get us started. I have to do this one little thing in here. I have to do this pen issue thing. All right, there we go. All right, so let's go ahead and talk about subnetting. Subnetting is a concept that came about with the invention of CIDR, or the Subnet Mask. And so I want to talk about how to do this or explain it in one of many fashions. So I'm going to explain it in different ways. But we'll just start with the basics. So the reason for subnetting is a couple of reasons. First off, one major reason is for the exhaustion of the IP version 4 space. So the exhaustion of IP version 4 space is eminent. In fact, you can go to ARIN, ARIN, the American Registry for Internet Numbers, and you can go look at their website right now. And they actually have a countdown timer for the exhaustion of IP version 4 addresses. See, when we first created IP, I say we, I include myself in the upper echelon of computer scientists, but I'm really not. I'm like bottom rung, very bottom rung. But anyway, I say we. I see the collective of computer science engineers. They created IP version 4, and when they first created it, they had no comprehension that we would ever need more than 4 billion IP addresses. In fact, they created these classes A, B, and C, and this was really big organizations. This was kind of medium, and these were small organizations. And of course, anybody who worked at an institution who has authored the original IP version 4 protocol, they all got to be big, right? They all got big. So they gave out all these Class A addresses to everybody, and everybody else got B's and C's. Well, we've ran out of these. I mean, we only have a few Class A's and Class B's left. But consequently, so subnetting was created to help temporarily solve this exhaustion of the IP version 4 space. The permanent solution is the creation of the IP version 6 protocol. That's the permanent solution, and I have a whole other presentation we're doing on that coming up. All right, second, this is the big one. This is actually the reason they had to do it. So this was the big reason, and that was the inability we'll call it route aggregation. So the inability to aggregate routes. See, the problem was, if you had the original IP version 4, the IP version 4 address is a 32-bit address. Well, 2 to the power of 32 is what? Right? Well, I'm lazy, so I'm going to break out my calculator. and I'm going to show you. So we're going to go to, what is it, scientific mode? Does that give it to me? Yeah. So 2, where's the little XY thing in here? There it is. To the power of 32 is, well, there we go. Oh, I don't know if I can paste that in here. Oh, I can paste it in there, but I got to do this. I got to go Alt, print screen. And then I think I can come back in here and I can go. Well, I'm not very good at this. There we go. Haha. So there is your 2 to the power of 32 is 4,294,967,296. That's how many possible IP addresses were available. So a couple of problems here. Well, there were a lot, and we won't talk about how many. I'll talk about that on Friday. But we have a lot of Class C addresses, Class C networks. These what the internet community called the small networks. There were a lot of them. There were millions of them. Well, the problem is that out of all these addresses that had to be routed, these had to create a routing table. And every entry in the routing table required the IP address, that was 32 bits, plus the gateway, that was 32 bits, plus a metric or whatever. So you basically had and then the subnet mask, or not the subnet mask, but you had the 32-bit address and then the gateway. So this is like, let's say 80 bits was required for an entry in the routing table. That's not exact, but it's close enough for what we're talking about. Well, every entry had to have 80 bits. Well, you can imagine back in the early 80s, we were getting to the point where we had to have an 8 megabyte routing table. Now, I don't know if you remember 1980, but I do. And 8 megabytes of RAM was A, not even possible, and B, if it was possible, would have been extremely expensive, right? I can't imagine. But that was the problem. We didn't have routers that were capable of showing the entire routing table. So route aggregation, the ability to summarize, and actually we'll call it, instead of aggregation, we'll call it summarization. And I believe that is a word in the English language, summarization. So we're going to summarize routes. So rather than saying 50 routes, I'll say one entry. So this is why we needed CIDR, or classless interdomain routing, or commonly called subnetting. Well, how did they do this? Well, they introduced the Subnet Mask. So if you had an IP address, we'll just go with 2 zeros. I'll use one of the college addresses. Let's say my IP address was 207.233.9.131. Let's say that was my IP address on the internet. And I was given a subnet mask. And let's say, and by the way, before CIDR, there was no subnet mask. But with the introduction of CIDR, they created a subnet mask. So the subnet mask, let's say I was given a 255.255.255.0 subnet mask. So I have a couple of rules that we need to get out the gate, or we need to get out right away. And this is the rule. Whenever you take an IP address and you AND it, and I'm going to write that over here, AND, not add, AND. Whenever you take the IP address and you AND it with the subnet mask, the result is the subnet ID. Always. So whenever you take the IP and you AND it with the mask, you get the subnet ID. That's a thing you always have to remember. But before we get into that, let's just talk about that. So I'm going to grab my calculator again, and I'm going to go. I'm going to take that 207. So I'm going to go to programmer mode, and I'm going to type 207, and I'm going to go to binary, and I've got, there's the binary equivalent, edit. So that's 1100 with 4 ones. So I'm going to write out the equivalent of that over here. So 1100, 1, 2, 3, 4. That is 207 in binary. Now I'm going to take 233. So I'm going to go back to decimal, 233, and I'm going to convert that to binary. So 1110. So 1, 1. I forgot already. 111 0 1 0 0 1. Right? And then we're going to do 9, which should be incredibly easy for you binary experts out there. But it's going to, now notice, the calculator does not give me leading zeros. Notice that? So I'm going to put in the leading 4 zeros. 1, 2, 3, 4, 1, 0, 0, 1. And then 131. So I'm going to go ahead and go to the decimal equivalent of that. I'm going to type 131. And I'm going to type binary, and in this case, it's 1 with 5 zeros and 2 ones. So 1, 1, 2, 3, 4, 5, 1, 1. So that is the binary equivalent of the IP address 207.233.9.131. Make sense? Now I'm going to take the binary equivalent of 255.255.255.0. Now you should know this, but for those of you who don't, I'm going to take 255 and I'm going to convert that to binary, and that is all ones. So 255 is 1, 1, 1, 1, 1, 1, 1, 1, and then 255 again is just a string of 8 ones, right? Now, on Friday, I talked about you have a routing device, and the routing device receives a packet through one interface. Hi, I'm the IP packet. Whee! Here comes the IP packet. The IP packet is coming into the router. The router has to make a very fast decision and compare the incoming IP address to its routing table. Routing table. So it's going to see the IP here and where it goes. IP, where it goes, right? Well, when the IP comes in, it doesn't look at the dotted decimal notation up here. It looks at the binary over here. So it makes a very quick decision. It finds out what the IP's subnet ID is. The routing table does not have IPs. The routing table has subnet IDs in here, or network IDs. That is what is in the routing table. So it needs to very quickly find out what the subnet ID is for the incoming IP. How does it do that? Well, it takes the IP address and it ANDs it with the subnet mask to get the subnet ID. Do you remember that? This is the important point. Routers and all other IP devices use the process of ANDing in order to compare the IP address with the subnet mask. So there you go, right? That's how it works. Now, let's talk about how ANDing works. Now, I have to give you a real quick crash course in logical ANDing. If you've taken a basic computer science class, you should get this. This is simple stuff. But let's just talk about logical ANDing. Now, I learned logical ANDing the hard way. I took a logic course from a Jesuit priest who only spoke Latin, or refused to speak English on most of the time, and he spoke Latin. And he was a Jesuit priest, and he believed that everything in the entire universe could be converted to a logical syllogism. And so he used ANDing all the time. Right? But he used it in a little bit different theorem, but it's always helped me to understand it, right? So if we have something that is, and I'll use his terms, if we have something that is of God and something that is of the devil, and you mix those two together, then the result is, well, that's devil. If you have something from the devil and you mix it with something that's godly, that is what? What do you think the Jesuit priest would say? Well, he would say that's from the devil. If you have something that is from the devil and you mix it with something from the devil, then you cannot get something that's truth out of it. You can only get something from the devil. If you get something from God that is also from God, then you are going to get something from God, right? So this is basically the Jesuit priest's idea. Well, how could we convert this to simple formula, right? Well, we could say, okay, God is truth. So truth and falsity equals false. A false and a truth equals false. A false and a false equals false, right? No way around it, right? That's just the way it works. And then if you have a truth and a truth, then that is true, right? Well, how would I convert this into computer science language? Well, that's pretty easy. A 1 and a 0 equals 0. A 0 and a 1 equals 0. A 0 and a 0 equals a 0. And a 1 and a 1 equals a 1. Make sense? This is called a logical AND. Or, in computer science terms, this is called an AND gate. Because when you have a transistor that can show 4 particular outputs, it could either be 0, 0, 0, or 1, right? So this is how you do it. And by the way, which is just a little sidebar, Boolean algebra can be solved for logical AND gates with set theory, which is really, well, it's mind-boggling to think that all this came together and we have computers. But I won't even go there right now. But you get the idea. This is what we call a logical AND gate, right? As taught to me by my Jesuit priest, critical thinking guy. So, go back up here. Routers use logical AND gates to determine the network ID, the subnet ID. So, let's take a look at it. So, we're back up here. We're right here right now. So, a 1 and a 1 is a what? It's a 1. A 1 and a 1 is a 1. 0 and a 1 is a 0. A 0 and a 1 is a 0. 1 and a 1 is a 1. 1 and a 1 is a 1. 1, 1. Do you see that? And so 1, 1, 1, 0, 1, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 1. Now, what is this thing called again? This is called a subnet mask. And do you see what the mask did? It masked the subnet ID. Do you see that? Because the subnet ID was produced. The ones basically produced the same thing that was up there before. So now what happens over here? 1 and a 0 is a 0. A 0 and a 0 is a 0. 0, 0, 0, 0, 0, 0. Convert this back to decimal. This is 207.233.9.0, right? So 207.233.9.131 when ANDed with this 255.255.255.0 subnet mask, right? When you take this and you AND it with that mask, you are on the subnet 207.233.9.0. The router would then look inside its routing table, find this 9.0 address, right? And determine where to send the IP packet. All right, that's your basic primer on ANDing. That's how ANDing works. Every IP address gets ANDed with the mask to produce the subnet ID. That's just basically how it rolls. All right. Let's keep going then. So we're pretty jazzed. Now, instead of writing, I want to talk about subnet masks real quick. Instead of writing 255.255.255.0, the binary equivalent of that is 1, 2, 3, 4, 5, 6, 7, 8.1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, right? That's the binary equivalent. This is the dotted decimal. This is the binary. So rather than, can you imagine you're on a phone call with a bunch of technicians and you're like, hey, Mr. Network Technician guy, I'm on a network and I'm on a 255.255.255.0. And he goes, wait, was that a 255.255.0.0 or a 255.255.255.0? No, it was a 255.255.255.128. Really? Was it a 255.255.128.0 or a 255.255.255.255.128? So you can imagine it gets really confusing with all these 255s. So instead, they came up with this thing called CIDR notation. And CIDR notation is you write the IP address down, and then you do slash and the number of bits used continuously. How many bits do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I'm using 24 bits contiguously in this mask. Therefore, I have a slash 24. So slash 24 equals 255.255.255.0. A slash 16 would be 255.255.0.0. A slash 8 would be 255.0.0.0. Right? So that's CIDR notation. Okay? So let's talk about subnetting now. So let's say I'm given a scenario where we'll just pick a real easy example for our class today. So let's say I'm given a scenario where, you know what? My network administrator has given me an address of 192.168.10.0 on a slash 24. Okay? You now know what that means, right? So what's the subnet mask? 255.255.255.0, right? So he's given me this, and normally, and so I have a router. So we'll pretend we're at the college. So here's the college net. And the college net connects up to my routing device. And I have an IP here. Let's say I have 207.233.9.10 here, and over here is the college network. He has given to me an IP address range that I can use internally on my network, and that is right here. This is the range he's given me. But let's say, now that he's given me that range, you know what? I would like, if at all possible, to actually break my network up into multiple networks. So I would like to break it up into we'll go with 6. We'll go with 6 of them. So I would like to break it up into the student network. I'd like to break it up into the servers. I'd like the server network. I would like to have my printers over here on one network. And I would like to have my wireless devices over here on this network. And I would like to have my, I'm running out of options here, teachers over here. All right, cool. And I want my devices over here, like my projectors and stuff. So I'd like to take this network, and so I call up my network guy. I call up the network LAN guy, the cool guy, because all LAN guys are cool. Hey, Mr. LAN guy, can I have... you gave me 192.168.10.0. That's great. And I can go and assign that. But, I'd really like to create 6 networks. So could you give me 5 more address blocks? And, of course, he's a network guy, so he's going to say, no, you can't have it because I am network god and you can't have it. So, I'm like, darn it, I would like to have more than one network. I just don't want to have one network. I want to have multiple. I want to break these up and subnet them so they can't talk to each other, and I can have more security and all that sort of stuff. So I'd like to break these up, and I'd like to control this a little better. Well, I only have one network address, and my network administrator is denying me the ability to have any more. Well, the answer is that I can take this and I can subnet it. Right? So the question becomes, how do I subnet it? Right? So there are many steps. First step. So I'll give you several steps. First steps is I need to figure out, all right, how many total networks do I need? Well, in this case, I need 1, 2, 3, 4, 5, 6. So in this case, I need 6 subnets. Now, I don't always know how many subnets I need. Sometimes I may need more. Maybe I wanted some growth in here. But I know that in this case, I need 6 subnets. Second question. I need to know how many hosts. Hosts per subnet. So how many hosts per subnet? And I'll write up here, subnets. How many subnets do you want? So how many hosts per subnet? So let me see. I go through here, and let's say I've got 20. I've got 20 students. I've got 10 servers. I've got 4 printers. I've got 10 wireless devices. I've got 5 teachers, and I've got about 25 devices. So in this case, and by the way, you have to count the router interface. So in this case, I have 21 required here, 11 required here, 5 required here, 11 required here, 6 required here, and 26 required here because I have to include the router interface. So the question becomes now, all right, so I need at least 26 hosts per subnet, right? Because my largest network has 26. So my largest network is 26. So I need at least 26 hosts per subnet. All right? Number 3. This one's easy. Some people freak out about it, but it's actually relatively easy. So the question becomes now, number 3 is, how many bits to extend my mask by? So how many bits do I need to extend my mask by? Well, let's go over here real quick. So I started with a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So this is my /24. Do you agree? So now the question is, how many bits do I need to extend my mask by to create at least 6 networks? So I could extend this by 1. So let's just practice. I could extend this by 1, and then I would have 7 zeros over here. If I did that, there's a quick formula for figuring this out. 2 to the power of 1 equals 2. This would create 2 subnets. Do you see that? How many host bits do I have? And these are my host bits. The zeros are my host bits. I have 2 to the power of 7 host bits. That's 128 hosts per network. Will this solve for what I'm trying to do? No, because I need 6 subnets with 26 hosts. It'll solve the number of hosts. It'll solve here, right? Because I only need 26. But I don't have enough subnets because I only have 2, right? So I got to maybe borrow 2 bits. So if I went .11 with 6 zeros, right? Then what would that be? So 2 to the power of 2 would be 4, which would be, well, now it would be 4 subnets. And how many host bits do I have? I have 6. 2 to the power of 6 is 64 hosts. Well, I have enough hosts, right? But do I have enough subnets? No, because I need 6. That ain't going to work. So .111 with 5 zeros for hosts. What does that do for me? Well, that gives me 2 to the power of 3, which is 8 subnets. And 5 hosts. So 2 to the power of 5 is 32 hosts per subnet. Will this work? Yes, it will, because I need 6, right? I need 6. I figured that out. And I need 26 hosts per subnet. I figured that out. And in this case, I have 8 subnets and 32. So that will work. So I've determined how many bits am I going to extend my mask by? The answer is 3. So I'm going to go 1, 2, 3. So the answer to this question is 3. Number 4. What is my new CIDR notation? So it was going to be 192.168.10.0/24, but because I borrowed 3 bits, it's no longer a 24, right? 24, 25, 26, 27. So this is now 192.168.10.0/27. Right? Because I borrowed 3 bits. Number 5. What is my new subnet mask? Well, the first 3 octets are easy, right? 255.255.255. I've got 3 1s and 5 zeros, right? Well, it's pretty easy to figure out. In fact, it's really easy to figure out when you use a calculator. So I'm going to go to binary here. I'm going to go 1, 2, 3, and 5 1s. 1, 2, 3, 4, 5, and I'm going to convert it to decimal, 224. So my new subnet mask is 255.255.224. All right? So now, number 6. What are my subnet IDs? So once I've created this subnet, I've actually created, how many networks did I say I was going to create? 8. I was going to create 8 subnets. So let's scroll down a bit, and we're going to create our, we're going to create our first subnet. Now, I'll just give you a hint. The first one is always 0. 192.168.10.0. That's the first one. The first one always is when all the host bits are set to 0. That's pretty easy to figure out. But now I'm going to go, going back up here, if I borrowed 3 bits, right? In fact, let me erase this right here. And let's draw this a little cleaner. Right? These are the 3 bits I borrowed right here. And these are considered my host bits right here. Host bits. How many host bits are there? There are 5. Well, 2 to the power of 5 is 32. So I know that every subnet I've created is going to go up in increments of the number of hosts I have per subnet, which is 32. So I know that every subnet is going to go up in increments of 32. So looking back over here, if I can find my thing, what would be the next one? This is the first one. What would be the next one? Right? If 0 is the first subnet ID, the next one is going to be 32. Now, remember I told you that other axiom that whenever you AND the network with the subnet mask, you'll always get the subnet ID. Here's your next axiom that you must remember. When all host bits are 0, you have the subnet ID. Okay? So when all the host bits are 0, you have the subnet ID. Now, let's just take a look at this. I want to convert 192.168.10.32 to binary just so you can see it. So we're going to go ahead and I'm going to go 192 and I'm going to convert that to binary. That's 2 1s and 6 zeros. And now I'm going to go 168 and I'm going to convert that to binary. That's 10101, 10101 with 3 zeros. Then I've got 10. Right? And then I've got 32. 128, 64, 32, and all zeros. Now, remember my mask, right? So I'm using a /27 now, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Where are my host bits? These are my host bits. What is the rule? When all of the host bits are set to 0, what do I have? Subnet ID. That is what this is. So 32 is when all the host bits are set to 0. All right? So what's my next one? 192.168.10, and I'm going up in increments of what again? 32. So my next one is 64. 192.168.10. Uh-oh, I'm in trouble now. I have to add. Oh no. What do you think? 96? There you go. Next one, 192.168.10.128. 192.168.10.160. 192.168.10. This one's pretty easy. 192. 192.168.10.224. Right? Now, how many networks did I say I would create? No. I said I would create 8 subnets. Because how many bits did I borrow? I borrowed 3 bits. So I'm creating 8 subnets. There they are. Those are our subnet IDs. All right, next step, number 7. Number the subnets. Okay, when you number the subnets, you must always number the first one as number 0. This is called subnet 0. The next one is number 1. Never start with the number 1. Why? Because 0 is a number. This is called the subnet 0. We actually refer to this as subnet 0. And the next one would be 2, next one would be 3, next one would be 4, next one would be 5, next one would be 6, next one would be 7. There are our 8 subnets. Okay, next. After we've numbered the subnets, right, then we are going to figure out what are the broadcast IDs. The broadcast IDs are, next axiom, when all host bits are set to ones, you have, well, I'll just put equal broadcast ID. Right? So the quick way to figure that out is the broadcast ID is always one less than the next network ID. So in this case, the broadcast ID is going to be 31 because it's one less than 32. The next one is going to be 63. The next one is going to be 95. The next one is going to be 127. The next one is going to be 159. The next one is going to be 191. The next one is going to be 223. And the next one is going to be, this is the hard part, 255, which is the last available IP in that block. So these are the broadcast IDs. Broadcast IDs. Subnet IDs, broadcast IDs. Next step. What are the host ranges? The host ranges are everything in between. So in this case, it would be, I won't put parentheses. In this case, it would be 1 through 30, 33 through 62, 65 through 94, 97 through 126, 129 through 158, 161 through 190, 193 through 222, 225 through 254. These are the host ranges. These are the available IPs to use to assign to machines. All right, that's it. That's pretty much how you create a subnet address. And you follow those basic steps. There's 3 more steps to follow, but those require us to actually implement devices. So we'll talk about that at a later time. Anyway, basically that's how you perform an IP subnet scheme, and that's how you create it. There you go. All right, we'll continue this discussion later. Thank you very much.